Morning. Today we're going to go through surface area. I believe you've been doing some area work or have done at some point this year with your class teacher. So we're going to take this on that step further and look at surface area. Our intention is to be able to calculate the surface area of cubes and cuboids, and then we're going to look at taking it into compound prisms as well. As we go through, this is going to be worked slightly differently to some of your other lessons, where we're going to go through, I'll give you the information on here for you to make your notes from, then you just need to pause when you're told to complete the questions, and then the answer will come up for you to mark, and you work your way through the video. If you have any issues or need any help with any of it, please email your class teachers, and they will be more than happy to help. So first of all, we're going to do a quick recap on area. So area is obviously the space within a flat shape, and we can see a basic example is a rectangle below, and you need two lengths to multiply together, and they need to meet at a right angle. This is the same for all area. So this one is just 4 by 6, so it's 4 times 6. It is crucial though we use the correct units of measure. We often see marks dropped at GCSE. So this is centimetres squared. The squared denotes it is an area unit of measure and not a linear, so a length measure. We then have some practice questions for you here. There is 12 for you to do. Please go through, sketch down the diagram quickly, show your calculation, so show the sum that you are doing, and then show your final answer with the correct units of measure. Pause the video now and then press play when you want to see the solutions. So the solutions. All the solutions are below. However, I have made 2 errors on here. Have a quick look through as you're marking, pause if you need to, and go through and see where you think I have made an error. Okay, so as for my errors, hopefully you've picked them out. So G, I've made a calculation error. So we often see this, but in a GCSE exam, I would still get potentially 1 or 2 out of my marks out of my question, because I've shown the calculation I want to use and I've shown the correct units of measure. The only thing I've done wrong is calculated it incorrectly, and I got 58 instead of 56. K is my other error, but this is just units of measure. So again, I would still be picking up marks because I've shown the sum that I want to do. I've made the correct calculation, but I've just used the wrong units of measure. And I should have used millimeters instead of centimeters as my units of measure. Right, surface area. All I want you to do for the moment is envisage how you would unfold a cube. This sort of thing we did probably done in primary school or even year 7, year 8. Can you draw a quick image of what your cube would look like? So there are 11 different ways we can unfold a cube. So we can get 11 nets of a cube. And here are all 11. The most common is that crucifix style that you can see on your screen in red. That there is no right or wrong as to which way you do it. It just comes down to preference and organization. So make sure that you are aware that there's different ways of doing it, and don't just look for the crucifix. So when we look at finding the surface area of a cube, we need to find the surface area of each of our faces. Now with a cube, it's relatively straightforward because all the faces are the same size. So when we go through and calculate this, we can find the area of one of our faces and then multiply it by 6. Or if we are less confident, we can find the area of all of it in total and just count up the centimeters squared. We need to be careful with this as the prisms and 3D shapes we get become more complicated. Doing this calculation becomes much harder if we try to use this method. We can see that I've just found the area of 1, which is 3 by 3. I have 6 of them, so I get 54 centimeters squared. I have 2 worked examples here. These should be relatively straightforward for you. So pause for a sec, make sure you show your calculations, and then press play just to double check. So the first solution, I have a face which is 5 by 5, giving me 25 centimeters squared. I have 6 of those at 25 centimeters squared each, give me a grand surface area of 150 centimeters squared. I should be showing exactly the same method for the 7 centimeter one. Given me 7 by 7 is 49 centimeters squared. 6 lots of those is 294 centimeters squared. It's now time for you to do some quick practice. There are 9 questions here in total, 5 with diagrams, 4 without. Just go through, sketch the diagram. You do not need to sketch a diagram for question 2, it becomes more theoretical. So pause the video, do your work in, show your solutions, making sure you use the correct units of measure, and then press play again to get your solutions. Here are your solutions. Go through, mark it. You should see 2 layers to your work in. We should not just see an overall answer. You must make sure you show it. Otherwise, marks are often lost in this topic. If you have any issues with any of these, please contact your member of maths staff and they will talk you through it. So cuboids. Cuboids are slightly more complex because not all the sides are the same. If we unfold this in the same method, we need to appreciate what the different rectangles represent. So I could use this front of the shape, the front of my cuboid, as this orange rectangle. If I then look at the bottom of my shape, or the top, that would be represented by a blue rectangle. This pattern is then repeated for the back and the underneath of my cuboid, giving me a net that looks like this. I then have my 2 sides, denoted here by the green rectangles, and they represent the 2 sides. I have to be careful when I put down my dimensions and make sure I allocate the right dimension to the right side. So the width of my orange and blue rectangles is 10. My height of them is 4 centimeters. I have 5 centimeters when the green side is allocated next to the orange rectangle. You need to be careful. If you have drawn out your green side to be next to the blue rectangle, these 2 dimensions will be swapped. I can then calculate the area of each rectangle and write them in. So to calculate the area of the green rectangle, I'm doing 4 times 5, which is 20, and I have 2 lots of that. I then can do the blue, which is 4 lots of 10, which gives me 40 each, and then 5 lots of 10 for the orange rectangles. And then I add them all together to find a total surface area of 220 centimeters squared. I personally don't like drawing out the nets. I find it takes too long, and I'm going to use the next method. When I look at this diagram, I appreciate the fact that there are 3 pairs of rectangles that are identical. I have the front and the back that are the same, I have the top and the bottom that are the same, and I have the 2 sides. I'm therefore just going to do my rectangle calculations and double them to give me the area of the corresponding rectangles. So first up is the front of my cuboid. That is 8 by 12 centimeters. So I do that calculation and get 96 centimeters squared. I have the front and the back, so I'm going to double this area to get a total of 192 centimeters squared. I'm then going to look at the sides. These are 5 by 8. So I'm going to multiply those together to give me 40, and I have 2 sides of my cuboid, giving me 80 centimeters squared. I then have the top and the bottom. So the top is 12 by 5 centimeters, giving me an area of 60 centimeters squared. I then have to double it for the top and the bottom to give me a total of 120 centimeters squared. I can then add these pairs of areas together, which means I'm going to add my 192, my 120 and my 80 together, giving me a grand total surface area of 392 centimeters squared. I find this method much easier and much quicker to use, especially when answering exam questions. You now have some practice to do. Please sketch down the rectangle. You can either draw out the nets or use the pairing method we've just done. Please show all your calculations. Please do not just give a final answer. You will find there is 1 mark for the final answer, and you will probably be allocated 3 or 4 marks for the question. Don't throw marks away because you're too lazy to write down the calculations. Pause the video now and press play when you want to see the solutions. So the solutions. Please go through, mark your work, make sure you use the correct units of measure. You will notice on here, hopefully, there are a couple of errors with the units of measure. You can see question E, I've just left a centimetre squared. And we often see this in the exam. You get into the habit of dealing with centimetres squared, and when it changes, we don't change it. So this answer here would be given as incorrect. I would get some method marks, but I would drop a mark. I also have made the same mistake on H, where this is in millimetres and some are in centimetres. So I need to consider what's gone on with H. I now have something for you to consider. Within our day-to-day life, surface area is used by many different industries. You need to go through and have a look and see if we can start to establish where these are used. I've taken this from a painter and decorator point of view. In order to give an accurate price for a job, I need to know how much paint I need to buy. In order to do that, I need to know how much area there is to cover. So I've taken this from my lounge. I've measured my walls, I calculated the surface area, I looked at the tin of paint and it tells me each tin of paint covers 12 metres squared. I know the cost of each tin. Your aim now is to find a room in your house, see if you can calculate the surface area of your walls. If you wish to just leave the windows in, that is fine and just treat it as a solid wall. If you wish to subtract that from your overall area, that is absolutely fine and would be a more accurate calculation. Pause now to complete the task and then press play to see a modelled example. Your modelled example comes up as follows. I measured my room and I had a total surface area of 55 metres squared. That means I'm going to need 5 tins of paint because they cover 12 square metres each. I will hopefully have a bit of paint left over to do any touching up maybe. Each tin of paint is £11, meaning I'm going to spend £55 in total. Surface area is obviously used in many different industries. We see this when people design boxes for packaging and they need to know the total surface area of packaging so they can allocate a cost to it. So surface area, especially when it comes to our industry, becomes really important. Here is your first of the challenge questions. Can you find a cuboid with edges of whole number length, so integer values, that has a surface area of exactly 100 square units? Is there more than one you can find? Can you find all of them if there is more than one? And can you provide a convincing argument that you have found all of them? Pause the video now and send your solutions to your teacher. I'm not going to give this away. This is a task that should probably spend 5 to 10 minutes attempting. Please don't spend any longer than that because there's more that we need to get through on this lesson. Compound area. We're now going to have a look at some compound area in order that we can move into compound prisms. In order to calculate a compound area, hopefully this is something you recall from previous lessons, we need to split the shape up into regular shapes. I've split this one up with a vertical line, giving me 2 calculations to do. I have my 3x4, which is 12 meters squared, and my 3x2, which is 6 meters squared, giving me a total area of 12 meters squared. Now over to you to practice. As this is a recap, this should be relatively straightforward. Just take care of how you split your shapes. Make sure you show all your calculations, as these often equate to 3 or 4 marks in the exam. Press play again when you want the solutions. So the solutions. I'm going to talk you through a couple of these. The first one, I could split vertically, giving me 2 areas of 7x3 and 5x3, giving me a grand total of 36 centimeters squared. I could, however, have split my shape horizontally, giving me 2 areas of 4x3 and 8x3. It does not matter which way you do it. Both of you give the same overall area. I have given you the overall area as answers. I've not gone through each individual one. I've split all of mine vertically pretty much. As you go through, check your answers, check the overall answer. If something's gone wrong, have a look through, and then we're going to talk through B. So when we get to B, we have to start calculating some of the missing sides in order to split my shape. And if I split it vertically, I know this area here is a 2 by 3. I know this is 7, but I don't know by what width. So I have to make a calculation. If my overall width of the shape is 6 and this length is 3, it tells me this has to be 3 as well, despite the diagram not looking like that. So that dimension there is 3 centimeters. I can now carry on as normal and calculate the overall area, and comes out as 27 centimeters squared. On the last one, again, if I split it vertically, I need to find the missing dimension here. And if I have this as 25 centimeters and the overall is 30, the missing amount is going to be 5 centimeters. Again, I can now make the correct calculation. Please check your work, make sure you mark it, and any queries, please email your teachers. Time to practice for you. So we're over now to have a look at what are known as compound prisms or L-shaped prisms. Take your time. If you can sketch the diagram out, you will find it useful when you look back through your notes. Try and calculate the overall area, split the shape up. If you can try and find the cheat, so the quicker way of doing this, please feel free and have a look. If not, I'm sure it is something that your teacher will show you when you get back to school. Pause the video now to complete the work and then press play to find the solutions. So the solutions, just check your units of measure. All of these are in centimeters, so you should have all centimeters squared. I've only given you the overall calculations. If you have any errors and you're not sure why they've come about, again, please email your teachers. Round to the next challenge question. So the challenge question we have here is a cube that has had a smaller cube chopped out of it and then stuck up in the corner. Your task is to find the total surface area of this shape. In order to do this, you need to make sure you split the shape up into all of its surface areas and find out how many surfaces there are. Total surface area is the final result you're looking for. Units of measure, these have been done as centimeters, so your final answer should be in centimeters squared. And if you want a hint, don't pause the video. If you want to just go for it now, go for it now, and then press play when you want the solutions. Good luck. So for the hint, all you need to do is make sure you have areas for 15 sides. There are 15 sides of this shape. Split them out. If you wish to try and number them, feel free, and then write down and work through methodically the area for each. Once you get to the end, add them all up and you should be there. Pause now if you have listened to the hint before you come to the solution. So the final solution, I believe this is 114 centimeters squared. There are 15 faces. We can see some of the easier ones are when it's 2 by 2, giving you 4 centimeters squared. That's also the same for these two back sides here. The underneath is 3 centimeters squared because you have this centimeters squared taken out of it. And the same for the front sides for these L shapes. We then have slightly more complex sides here that we can't see. You just have to go through really methodically. Also take care not to have forgotten the bottom of the shape. This is often forgotten about when we do exam questions, and again, easy marks are thrown away. I hope you've enjoyed today's lesson. Hopefully we will have another one of these next week, either on more complex surface area or on volume. Enjoy the rest of your weekend and make sure you keep up with your maths.